Hi students, welcome to physics classes. Now we'll discuss two-dimensional motion. Two-dimensional motion. Now here we have in a coordinate system, three axes are there: x, y, z. Now to describe any object's motion, if we require two coordinates, either xy or yz or xz, any two coordinates are needed to describe the motion of the body, then it is two-dimensional motion. Two coordinates are needed to describe the motion of the body, then it is said to be two-dimensional motion. For example, if anything moving in a plane, for example, motion of the ball in a billiard game, or an athlete throwing a javelin, are examples of motion in two dimension. Now here we will discuss projectile motion. Now projectile motion. Now if an object is projected other than 90 degrees, with horizontal, then that motion is known as projectile motion. Now path taken by the projectile is parabola. Now here we have three types of projectiles. In that, first one is oblique projectile. Now oblique projectile means x-axis, y-axis. Now here if you project anything like this, it will take this path. This is oblique projectile. Next, second one, horizontal projectile. Now if any object projected like this, it will take this path. Now it will be taken as x-axis and it will be taken as y-axis. Now if any object is projectile from a top of a tower horizontally, then it is horizontal projectile. Next one is projectile on inclined plane. Means now this is the surface. By making an angle theta with the horizontal, this can be taken as x-axis and it can be taken as y-axis. Now if you project anything here, it will take this path. This is projectile on inclined plane. Now from these three, each one we will discuss clearly. Now first we'll discuss here projectile motion, oblique projectile. Now this is the surface. This can be taken as x-axis and this is y-axis. Now this is the origin O. Now from here onwards, if you project anything, an object projected from point O, by making alpha with horizontal, by making an angle alpha with horizontal, and the initial velocity given is u. From the point O, an object is projected with an initial velocity u and by making alpha with horizontal surface. Now when we project like this, it will take parabolic path and reaches a maximum height A, and again comes down and falls on the surface. This point is taken as A and falls at a point taken as B. Now here this O is known as point of projection. O is what? Point of projection. Here onwards the object is projected, no? So O is point of projection, and this alpha is angle between projected path and horizontal is known as angle of projection. Alpha is angle of projection. Now the distance from O to B, the distance from O to B is known as horizontal range. Horizontal range. Note with R. Now A is the maximum height. A is the maximum height. This height taken from the surface at a point we can take it is C. This AC is known as maximum height, is a capital H. Maximum height, capital H. Now the time taken by the particle in this path, time taken, it remains in the air. The time taken by the body in the air is known as time of flight. It remains in the air is known as time of flight. Now we have equations of motion. V equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. These equations we can write in two-dimensional. If the body moving in along x-axis, it can be written as Vx equal to ux plus axt, and Sx equal to uxt plus half axt. So all components are taken in along x-axis, half at square. Vx square equal to ux square plus 2ax sx. If it is moving in y-axis, in the direction of y-axis, then it can be written as all x is replaced with y. Vy equal to uy plus ayt. So this means velocity in direction of y, velocity in x-axis, velocity in x-axis direction, acceleration in x direction, displacement in x direction. Second equation, sy equal to uyt plus half ayt square. Vy square equal to uy square plus 2ay sy. These are the equation along x-axis and along y-axis. Now this projectile motion, two-dimensional motion. Projectile motion, two-dimensional motion. It can be discussed horizontal motion and vertical motion. Horizontal motion along x-axis direction, vertical motion along y-axis direction. These two motions takes place independent each other. So as x-axis horizontal motion, y-axis vertical motion, they won't depend on each other, independent each other. And this velocity of the particle, for example here if the velocity is projected like this, it can be resolved into two components. If it is making alpha with x-axis, then x component is, if a velocity u cos alpha, and y component u sin alpha. It can be resolved into two components, x component and y component. This horizontal component is remains constant, unchanged throughout the flight. Throughout the motion of the body, this x component is unchanged, and y component continuously affected by force of gravity. Continuously affected by force of gravity. So here horizontal motion is uniform motion. Horizontal motion is uniform motion, and vertical motion is uniformly accelerated, uniformly accelerated and retarded, uniformly accelerated and retarded motion. As here body is moving in a two-dimensional motion, it can be discussed in two components, x and y, and both are independent each other. Now velocity of a projectile is resolved into two components, horizontal component and vertical component. This horizontal component is a constant, unchanged throughout the motion, and vertical component is affected by force of gravity. So horizontal motion is uniform motion, and vertical motion is uniformly accelerated or retarded motion. Vertical is uniformly accelerated, retarded motion. Now oblique projectile. Now it is a x-axis, y-axis. Now if an object point O, if it is projected with initial velocity u by making an angle alpha with horizontal surface, it will move in a parabolic path. Now here it is close to the surface of earth. From O to at maximum height A, this is maximum height h max, and distance it covered and reaches at B, that is horizontal range R. Now we'll find maximum height. H max. Now how to find it? Now here maximum height means the body reaches to A, maximum height. When it is going into maximum height, initial velocity is u. Initial velocity is u. It resolved into two components, x component, y component. As it is making alpha here, uy equal to u sin alpha, and while reaching maximum height, final velocity vy equal to 0. At maximum height, velocity becomes 0, and acceleration as it is going away from the surface of earth minus g, and the height it covered, displacement becomes sy, maximum height h max. Now from the equation v square equal to u square plus 2as, v square equal to u square plus 2as, that will substitute. Vy is 0 equal to uy square, u square sin square alpha plus 2ay minus g h max. So we can write u square sin square alpha minus 2g h max. So if it is going opposite side, 2g h max equal to u square sin square alpha, and we want to find h equal to u square sin square alpha by 2g. This is the maximum height reached by the body in projectile motion. And here if alpha equal to 90 degrees, alpha is the angle of projection. If it becomes 90 degrees, so body will go up straightly, then h max equal to u square by 2g. Sin 90 value 1, no? Sin 90 value 1, so u square by 2g. So h value is maximum when alpha equal to 90 degrees. Now time taken to reach maximum height. Time taken to reach maximum height. Time of ascent. Time of ascent. That we will calculate now. Now, as it is going upward at maximum height, we already seen Vy equal to 0, Uy equal to U sine alpha, and A equal to Ay equal to minus G. So, you will take equation 1. V equal to U plus A T. V equal to U plus A T. Now V is 0, U sine alpha minus G T. So if it is coming in opposite side, plus T equal to U sine alpha divided by G. This is time of ascent. Time taken to reach maximum height. Time taken to reach maximum height, as well as time of descent also will be same. Time taken to reach the ground, from maximum height to ground, U sine alpha by G. Time of descent. So total time it remains in the air. Time of flight. Total time it remains in the air. Time of flight equal to time of ascent plus time of descent. We can write 2U sine alpha by G. Time of flight equal to 2U sine alpha by G. Now, horizontal range. Horizontal range in the sense, if a projectile takes this path, this distance covered along x-axis is horizontal range. It can be taken as a displacement on x-axis also. It can be taken as displacement on x-axis. Now here, to find displacement on x-axis, we can use S equal to ut plus half at square. S equal to ut plus half at square. And even we discussed acceleration along x-axis. We discussed this. Body, when it is in oblique motion, oblique projectile, horizontal, while taking horizontal direction, motion is uniform. If the body is in uniform motion, acceleration is 0. Acceleration is 0. Only we seen it acceleration becomes acceleration due to gravity, and it affects in vertical motion only. Now in the horizontal, no need to take A. Now Sx is the range, R equal to U along x-axis. U along x-axis. U is resolved into two components, x component, y component. So it becomes U cos alpha. U cos alpha. T, total time it remains in the air. T means total time it remains in the air. So time of flight, we already found 2U sine alpha by G plus half at square becomes 0. No need to substitute. Now see here, it can be written as 2U square cos alpha sine alpha divided by G. Can we write it is U square into 2 sine alpha into cos alpha divided by G. 2 sine alpha into cos alpha. 2 sine alpha into cos alpha. 2 sine alpha cos alpha equal to sine 2 alpha. Now if you substitute it here, U square sine 2 alpha by G is the horizontal range. Horizontal range equal to U square sine 2 alpha by G. Now here we know sine values from 0 to 1. Sine value changes from 0 to 1. 1 is the maximum. 1 is the maximum. So if sine 2 alpha becomes 1, range is maximum. Sine 2 alpha becomes 1, range is maximum. When range is maximum, when sine 2 alpha becomes 1. Sine 2 alpha becomes 1. So 2 alpha equal to 90 degrees. When we will get 1 in sine 90 degrees, then alpha equal to 45 degrees. Alpha equal to 45 degrees. So if alpha equal to 45 degrees, range is maximum. Alpha equal to 45 degrees, range is maximum, that we can write r equal to u square by g. It is when alpha equal to 45 degrees. Okay, now here one important thing you see, for a given value of u, for a given value of u, if you project with alpha, angle of projection alpha and 90 minus alpha, for a given value of u, if you project with alpha and 90 minus alpha, horizontal range is same. Horizontal range is same. Now that we will see here. Now r, for alpha we have seen r equal to u square sine 2 alpha by g for alpha. Now we will see for 90 minus alpha, r for 90 minus alpha equal to same u square sine 2, instead of alpha we can write 90 minus alpha by g. So u square sine 2 into 90, 180 minus 2 alpha. We know sine 180 minus theta equal to sine theta. So u square sine 2 alpha by g. So 90 minus alpha equal to alpha. So whenever they have given 30 degrees and 90 minus 30, 60 degrees, horizontal range is same. If they given r for 20 degrees and 70 degrees, alpha 90 minus alpha, r range, horizontal range is same. Important. Even here one thing, time of flight, maximum height are different. Time taken in the air and maximum height are different. R value is same. R value is same. Okay. Next one is instantaneous velocity for oblique projectile. Now instantaneous velocity means velocity of the body at any instant given time. Now when it is in projectile motion, we know vertical components are changing, horizontal components are not changing. So velocity equal to plus instantaneous velocity equal to vxi plus v by j. So here magnitude of velocity equal to vx square plus vy square. Both are perpendicular, no? So that now vx velocity in horizontal direction, horizontal component u sin u cos alpha, vertical component u sin alpha. So u cos alpha square plus while coming to the vertical component, it is not constant, so we will use v equal to u plus eat. So vy square equal to u sin alpha, y component, no, u sin alpha minus g t square. This is the instantaneous velocity. Now what is its direction? Tan theta equal to y, velocity along y component by velocity along x axis, that equal to u sin alpha minus gt by u cos alpha is the instantaneous velocity and its direction. It is the magnitude and it is the direction. Now equation of trajectory. Now a projectile thrown with a velocity u in a horizontal direction by making an angle alpha with a horizontal x-axis. Now this u can be resolved into two components, ux equal to u cos alpha and uy equal to u sin alpha. Then horizontal motion, for horizontal motion x equal to u into t plus half a t square. Now while horizontal motion a becomes 0, we know, so u cos alpha into t, u cos alpha into t time. So we can write t equal to x by u cos alpha. Now if you take a vertical motion y-axis equal to, in y-axis direction acceleration also there, ut u sin alpha into t plus half gt square, no, g value minus half gt square. Now we can write y equal to u sin alpha into t. T already we have here, x by u cos alpha minus half g t square, x by u cos alpha square. So here u gets cancelled, sin alpha by cos alpha becomes tan alpha, x tan alpha minus half g x square by u square cos square alpha. Now here if you take x tan alpha common, x tan alpha if you take common, then what is remaining? 1 minus g into x already went, x divided by u square cos square alpha, tan alpha if you take common here, tan alpha. So tan alpha means we can write sin alpha by cos alpha, sin alpha by cos alpha. Cos alpha here one time cancel, you will get 1 minus gx divided by 2u square cos alpha into sin alpha equal to x tan alpha. Now here x tan alpha as usual, 1 minus g divided by 2u square cos alpha into sin alpha, 2 sin alpha cos alpha becomes sin 2 alpha divided by g is a formula for range, so x divided by r, y equal to x tan alpha into 1 minus x by r is a formula. Okay, thank you for watching. Please subscribe for more updates.